there. So we're gonna add on to our notes from before. Let me go to our 490 stuff, and we were talking about logs. And, you know, logs are different. You guys haven't seen those before. You might have seen them a little bit, but, you know, probably not that much. And that's why, you know, especially high achieving students like you guys, it freaks you out a little bit. Because you're like, what is this? What is a log? I mean, what does that mean? And it's totally different. It's a function. So a log is a function that does something. So let me explain it a couple ways. Okay, first we're going to evaluate logs. And so if I write like this, if I write log, that's the function, log, it's for logarithmic. They all have a base. The base is written as a subscript. So let's make this log base 2. Okay, so the 2 is written, you know, below the log and smaller as a subscript. So log base 2 of 32. Now here's what's weird about this. That is actually a number. You don't think of it that way. Like if I said, hey, think of the number 10, you all think of the number 10. If I say, think of log base 2 of 32, you don't think of a number, but it is a number. Because what the log function does, this is what it means. It means the base to what power equals this. That's what the function does. So what this question is asking right here, it's saying 2 to what power is 32? That's 2 to the 5th. So log base 2 of 32 is 5. Okay, it's the same as the number 5. It's the number way, another way of expressing it. So if I said, all right, so let's find the log base 3 of 81. We want to evaluate that. That question is asking 3 to what power is 81? Well, 3 to the 4th is 81, so that equals 4. Okay, so you can see why we started off with the Kahoot that we did, you know, knowing those, you know, integer values to powers are going to be helpful as we're doing this. Give you another one here. If I write log and I don't write a base, if you don't write a base, what is it? 10. Very good. Okay, so remember, it's base 10 if you don't write anything. So if I wrote common log of 100, that question means 10 to what power is 100? Well, 10 squared is 100, so that equals 2. Are we okay so far? So, you know, in thinking of it as a function, you know, we did the function boxes, and inside the function box, you have a log of a certain base. So, right, if I, you know, if inside the function was log base 2 of x, that would be our function. And we are going to drop stuff into the function. So if I drop like a 16 into the function, it's going to find log base 2 of 16, and the output would be 4. Okay, the input is what goes here, and the output is what it's evaluated.
Sure, Connor.
All right, you guys with me so far?
I have a question.
So I did a common log one. I probably should do also a natural log. So if we did, let's say, ln, what's the base of ln? E, very good. So this is base E. Remember, E is also a number. E is like 2.7, okay? So just like pi, if I say, hey guys, what's pi? You guys would all say, it's about 3.14. E is the second most famous irrational number. It is about 2.7, but it's irrational. It keeps going on forever. And it's second most popular because everybody learns pi earlier because you got to do geometry earlier. But E actually has tons and tons of applications when it comes to real life exponential growth, which we'll get into. You got a question?
No, they said something about like.
Oh. Uh-oh. All right, so let me check this. Yes, I am looking at the chat. Thank you. I appreciate though. Hey, you can't hear what I'm saying. Does that mean you can't hear me? If you could please chat back for those of you at home. You can't hear me at all, or you can't hear me because I'm too far away.
I had a
We can
question.
hear you, but Vince had a question.
All right. Oh, we can hear you. You can't hear us. Aha. All right. So now let me try this. Thank you for bringing that up. I may have needed to change my speakers, my output of my speakers, because it sends it to the overhead. All right, let's see. Melissa, can you just speak something right now so I can see if I can hear you?
Sure.
Oh, there you are. Now I can hear you. All right. Does anybody have any questions? Feel free to speak at home or in here.
I had a question.
Yeah, what's up?
I'm confused by the second example. Like, how does 4 times 4 does 4 equals 81?
Okay, so log base 3, yeah, I got you. Log base 3 means 3 to what power is equal to 81. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's why the answer is 4. So I think you're just reading the numbers in the wrong order. So the question is
Yep.
asking 3 to
No,
what
no, no,
power?
no.
Yeah. Yep. No, good question. Anything else, guys? All right. So let me get back to, we had this ln, remember that's log base E. And if I had ln of e to the 5th. All right, you ready for this? This should be the quickest, easiest problem you ever did in your whole life. The answer is, anybody know? The answer is 5.
What does E stand for then?
All right, E is a number. The number is about 2.7. It's an irrational number, okay? So, but what this is saying here for natural log of e to the 5th, that's saying log base e, because ln means log base e of e to the 5th. Well, think about that in terms of logs, how I tried to explain it. What this is saying is e to what power is e to the 5th? Well, it's to the 5th power. Okay, or another way to think of it is these two operations cancel each other out. Remember, logs and exponential functions cancel each other out. And so the answer is just equal to 5. So that one with the E is a little bit different. Somebody asked a good question. What if I did the natural log of 1? Well, let's see if anybody gets this. So that's asking e to what power is equal to 1? No. E to the first would be E. Very good. E to the 0 power is equal to 1. Remember, anything to the 0 power is equal to 1, right? Okay. Makes sense? You know, same if I said log base 5 of 1. That's also equal to 0. Because that's saying, you know, 5 to what power is equal to 1? Well, 5 to the 0 is equal to 1. All right. Any questions on that before I move on a little bit? All right, good. All right, so I know this is different for you guys, right? I mean, it's like the arithmetic of it isn't so bad. I mean, you guys can do, you know, 3 to the 3rd or whatever, but it looks different. And so that is going to freak you out for a little while. Don't worry about it. We're going to get there to where it looks natural. All right, so our next part, we are going to condense logs. And what this is going to be is just a couple of rules, which we'll then have to put into application later on. I just don't want to throw way too much stuff at you in one day. But to condense logs, there's some rules that we follow. Okay, the first rule is if you have two logs, okay, so that of the same base. So let's say we had log base 5 of x plus log base 5 of y. If I want to combine those into a single log, when I combine them, addition means I can multiply these two things. So I can write this as log base 5 of x times y. So when you condense them, addition becomes multiplication. Subtraction then would become division. So our second rule, and there's 3 of them, our second rule is if I had log base, and I'll just use variables, log base a of x minus log base a of y, that would equal log base a of x divided by y. So you want to just kind of remember that when you're condensing, addition becomes multiplication, subtraction becomes division. And then the third one is there's a power rule. If we had, let's say log base b of x to the y power, we can write that y out in front here as a coefficient. So that can be written as y, whoops, sorry, didn't write that correctly, scratch that, y times log base b of x. All right, so here would be an example of a problem we would want to condense. So let's say we had log base 6 of x plus 4 log base 6 of y. All right, now I'm going to do this all in one step. So it's going to be a couple things going on here. Addition means I'm going to turn it into multiplication. Any coefficients mean those are going to become an exponent. So when I combine these, that combines into log base 6 of x times y to the 4th. Okay, again, I got y to the 4th by taking that 4 and putting it there. That gave us the y to the 4th. And I multiplied them because it was addition. All right, let me give you another example. Let's say we had 6 common log of r plus 8 common log of c. All right, when I add them together, that's going to become multiplication. That's going to be r to the 6th and c to the 8th. So as a single log, I would write that as the common log. Remember, it's base 10, so I'm not writing that. Common log of r to the 6th, c to the 8th. All right, how are we doing so far? Okay. All right, well then we'll throw you another one here. All right, let's do 2 natural log of x plus 3 natural log of y minus 4 natural log of z. Now the coefficients are going to be the exponents. So that's going to be x squared. That's going to be y to the third. That's going to be z to the fourth. I'm going to multiply the first two and divide by the last one. So when I combine this, it's going to be the natural log of x squared, y to the third, divided by z to the fourth. All right, I'm going to have you guys try a couple on class kick. Are there any questions before I do that? All right, let's go over the class kick here. So for the first one, you know, we're the function of log. This means 3 to what power is 27, and 3 to the third is equal to 27. So that equals 3. For the second one, remember it's base 10 because it's common log. So that means, and sometimes students like to just write it in there, and that may totally help you at the beginning. So that means 10 to what power is 100? 10 squared is 100. Okay, we had a couple people have 10 here, so just make sure that you got 10 squared is 100. The next one, this one got a couple of people. I know that 3 squared is 9, but I want it to be 1/9. How do I get that on the bottom? Well, I have a negative there. Okay, so that equals -2. And think about that. That's because 3 to the negative second is equal to 1/9. Okay. So in a similar way, then the next one, I know 2 to the fourth is 16. So that's going to be -4. All right, any questions on the first page? Good. All right, we're moving right along here. Second page, so we are condensing these. And so this one is addition. This is going to become an exponent. This is going to become an exponent. I'm going to multiply. So that is going to be log, common log, I guess, so base 10 of x to the 6th times y to the 4th. For the second one, this becomes exponent, this becomes exponent. This means we're going to divide. So that's going to be common log of b to the 4th over c to the 3rd. All right, and then last but not least, don't forget this is log base 4, so I need to write that in my answer. That's going to be log base 4 of y to the x divided by,
That's x.
sorry?
That's x to the x. What do you-
Y to the x. What did I- Oh, I said y to the x. I wrote x to the x. Thank you. All right, so y to the x divided by a to the 3rd. Yes, thanks. All right, think we got it for today? Okay, and if we did something like this, just for maybe to connect a couple of things, if I had log, let's say base 3 of 9. What is log base 3 of 9? 2, right? Because 3 squared is 9. So that's 2. If I wrote this, log base 3 of 9 plus log base 3 of 9, if I used my combining rules, I could write that as log base 3 of 9 times 9, which is 81. And this is 4, right? 3 to the 4th is 81. Which is the same thing you get as if from the beginning you did them separately. Log base 3 of 9 is equal to 2. Log base 3 of 9 is equal to 2, and 2 plus 2 is 4. Okay, so like the rules hold. And obviously we'll get these into some more complicated problems when we start to get these rules down pat. Any questions for me before I turn you guys loose with the delta math? Anybody at home?